Hello guys, today I'm going to configure this static net. For that, to configure the static net, I'm using two 1841 series router and one switches, three computer and server. I will show how to make a topology. So before that, I'm writing the topic of today. That is, we are going to test and configure static net configuration and testing. For that, to configure the static net, I am using two router. The router is series of 1841. So just select and drop as shown in the packet tracer, and then I'm using a 2060 series of switch and three host devices, as shown in topology PC, like this: PC0, PC1 and PC2, and also a server. So these are the devices that I'm using to configure and testing of static net. Before making a connection between the router and router to switch and switch to PC, I'm going to add WIC2T module on both the router, because these two routers doesn't have any serial port. So to make a WAN connection, I'm using WIC2T model as shown in figure. So before adding the module, we need to switch off the router so that we can add the WIC2T model. So let's see. I just simply drag and drop the WIC2T model on slot 0, and after that I just on the switch of router 0, and then the same task will be done in router 1 too. So first go to router 1 and then switch of the devices, and then simply drag and drop WIC2T on a slot 0, and then open the on the switches. So this way we just add two serial port on both devices. We can see serial 000 and serial 001, and also in router 1 serial 000 and serial 001. This is a serial port to make a WAN connection. And now we go to the connection section, and then we choose a serial DTE cable to connect the router 0 and router 1. So let's connect first router 0, and I'm using router 0 I'm using serial 000, serial 0/0/ port of router 1, and to the serial 0/0/0 port of the router 1, that is router 0 and router 1. I just use serial 00 port. And after that, now we have to use copper straight through cable to make a connection between router to switch and switch to PC. So let's connect the copper straight through cable, router 0, and for the LAN connection I'm using fast Ethernet 00 port to switch. We can use any port of the switch. For now I am using fast Ethernet 0/1, and then fast Ethernet 0/2 with PC0 as shown in figure, and then fast Ethernet 0/3 to PC with PC1, and then fast Ethernet 0/4 to PC2 as shown in the topology. And here also the router to server connection is some kind of similar devices, like devices I mean, and for the like devices we must use a copper crossover cable. So just select the copper crossover cable and choose the FA00 of a router 1, and then server fast Ethernet 0 port. So basically we just created our topology. Now we'll assume the IP addresses to each interfaces and as well as host. So just assume the IP address we are going to use. For my case, I'm just using 10.0.0.0.10 and 10.0.0.20, and for PC2 I'm using 10.0.0.30. So these are my assumptions. I just assume the private IP of class A so that it can be mapped into public IP. We'll map this private IP into public IP later. So these are the private IPs of class A, and let's assume the server has a private IP like 192.168.1.10 of /24 network. This is my assumptions. And for the WAN, I'm just using public IP 100.0.0.1, and for the router 1 I'm using 100.0.0.2 as shown in the figure. So this is the assumptions of IP address what I'm going to use, and my assumption this connection can be known as LAN 1 and LAN 1. This can be considered as LAN 2. This is my assumption just, and this will be our WAN. So let's just define the size of the network before going to configure the LAN in WAN. So for LAN 1, we are using the private IP of class A, and its size is 10.0.0.0/8. For LAN 2, we are using class C IP 192.168.1.10/24 and /24. And for WAN connection, I'm using 100.0.0.1 of /8. This is also class A. This IP also belongs to class A. So these are my assumptions that I'm going to use in my topology. So basically we can identify that the LAN 1 contains private IP 10.0.0.0/8, and also the LAN 2 carries private IP of class C 192.168.1.10/24, and the WAN connection uses the public IP as 100.0.0.0/8. So these are my assumptions. So before going to static NAT, we must need to configure the basic configuration of PC as well as the routers. We do not need to configure the switch here. So let's go to PC and then assign IP address. To assigning the IP address on the host device, just click on the icon, and after that pop-up windows will be open, and then go to the desktop, and after the desktop we need to go on IP configuration, and this is the class A IP address. So the IPv4 address for the PC0 is we'll write here as we assume 10.0.0.10. So this is the class A IP, so its default subnet mask will be 255.0.0.0. In our case, we assume the gateway for the LAN 1 will be 10.0.0.1. So this is the IP address of PC0. We do not need to configure the DNS server for now. We can also write the gateway here like this 10.0.0.1, and the gateway for the router to server will be 192.168.1.1. In general practice, we use the gateway just below the IP address, just below the network ID, So these are the gateways. Then also we need to go on PC1. Let's go to the PC1. Same procedure, click on the PC1, a pop-up windows will be open, then go to the desktop, and after that in IP configuration, and then we'll type the IP address as you assumed. For PC1 it is a 10.0.0.20, and its subnet mask will be default, that is 255.0.0.0, because it is a /8 network. And for the default gateway, for the LAN 1, the default gateway is a 10.0.0.1. DNS server will be ignored for now, and then let's go to the PC2, and then desktop, and then IP configuration, and just type the IP we have assumed that is the IP we have assumed is 10.0.0.30, and its subnet mask will be 255.0.0.0, and its default gateway will be the same for the LAN 1, that is the gateway for the LAN 1 is 10.0.0.1. We must understood that the gateway for a single LAN, a same LAN, will be same for all the hosts. So this way we just assign the IP address to the each host. Now we assign the IP address to the server, because first we assign the IP address to the host and then we go to the router. So this is the same way as we configure the IP in PC. Server can be configured in the same way. Just click on the icon and then go to the desktop, and after that we can find the IP configuration box. Let's go into go into that and then assign the IP address as we assumed. So for server 0, we have assumed the IP address like 192.168.1.10. This is a class C IP and classful IP addressing. We do not change this net number of network bit. So its default subnet mask will be 255.255.255.0, and the default gateway, as we assumed, it is 192.168.1.1, and for now DNS server will be ignored. So this way we can just configure the IP of PC0 as well as PC1, PC2, and similarly server 0. So basically we just assign the IP address on PC as well as server. So for now we are going to configure basic configuration on router 0 as well as a router 1. So before going to router 0, we must understand that router 0 has a two interface, serial 000 and FA00. FA0 stands for fast Ethernet 0, and fast Ethernet 00 we assume IP as 10.0.0.1, and for serial 000 we assume IP 100.0.0.1, and the size of the network is already mentioned here. So we can go to the any interface before we can go to the any interface, I mean we can go to the LAN as well as a WAN. There is no reason to do first the LAN or either the WAN. So now let's go into the router. For that just single click on a router, a pop-up windows will be open, and then for easiness I am just maximizing it, and after that we are configuring the IP through the CLI mode, that is a command line interface mode. So just click on the client the command line interface mode, and the screen will be shown like this, and it is asking us, would you like to enter the initial configuration dialog? So it is asking about us if we want to make a username and password for the accessing the router, we can just do yes here. For the testing purpose, we are doing that. We are doing for the testing purpose. So we are not going to make a username password. So we can ignore that. So to ignore this, we just write here no, and just click on enter. We can click on enter as many times as you want. It is not necessary to just to enter one times or two times, whatever you like. Then a symbol will be then a symbol will be shown as a router greater than symbol. So it is called a user mode. It is called user mode. So you so first is a user mode, and after the user mode we need to go on a privilege mode. So for that we need to put a command enable. So after enable, after typing the enable, we just click on enter. So a new symbol will be represented as router husky. So this is called a privilege mode. This is called privilege mode. So privilege mode is also known as a read mode. We can just read the data from the router. So this is a privilege mode, and after the privilege mode we go to the configuration mode. So to go the configuration mode, we need to write a configuration terminal configuration terminal. Sorry, is the spelling is right? Terminal. So just type config, just type config, and then press the button tab config, and then just type tr terminal, and just type configure terminal. Sorry, I just write a wrong command. It is a configure terminal, not a configuration terminal, so it is my fault. So we just need to correct that. I'll just type configure terminal. So this is called a configuration mode. And now we are assigning to IP address to the interface, to the port. So we must go to the interface mode. So be careful. Firstly, we are on a user mode. After user mode, we went to privilege mode, and then configuration mode. Now we are in a configuration mode, and to assign the IP address, we must need to go on interface mode. So to go to interface mode, we need to type the command as interface and then tab. Now we are going, firstly we are going to configure the IP on LAN. So the physical address of LAN was interface fast ethernet 0/0, interface fast ethernet 0/0. We can also observe it from the topology. So that is, this is a fast ethernet 0, this port FA00. So we are on FA00, and for the FA00 we assume the IP address 10.0.0.1. So let's assign the IP address. So we are on router 0, interface fast address. To assign the IP address, there is a the command of to assign to the IP the command to assign the IP address is first we need to write IP, and then IP address, and then IP. The assumed IP is 10.0.0.1, and then we need to also mention the subnet mask. So it's default subnet mask. So it is of /8 network, so it has a default subnet mask, and it is 255.0.0.0.0. and then we need to make this port manually off. Initially it is on down state, so we manually need to make off. So for that we put a command like no shutdown. So this command will make off to the port, as we can see, change its state to off. So we just assign the IP to the fast ethernet 00. Now we are going to assign the IP address to the serial 000 port, that is in WAN port. And for the serial 000, we assume IP address 100.0.0.1. So let's do that. Let's go to the router, that is router 0, and we are on an interface, that is we are on a fast ethernet 00. So first we need to exit from that port. For that we just type a command exit, and then we go to the interface serial 0/0/0 as shown in a topology, as in our topology. So we are on a serial 000. So for serial 00, we assume a IP address 100.0.0.1 of /8. So we need to assign the IP address. For that we have a command IP address and then 100.0.0.1, and then we need also mention the subnet mask, and it has subnet mask 255.0.0.0, and then just type no shutdown to make off. So this and then we just end this configuration. That is, after typing the end, we return to the privilege mode, from where we can see what we configure. For that we can use a command show IP interface brick. This command will show our work. So our work was fast ethernet 000 contain 10.0.0.1, and it is a manually off, and also serial 000, it contains 100.0.0.1, and it's showing down because the serial 00 port of router 0 is connected to serial 00 port of router 1. So if router 1 if the port serial 00 of router 1 will be off, then router then serial 00 of router 0 will be also off. So no worry for now, just we configure and ignore this for now, ignore this for now. And then we go to the router, we go to the router 1, this router, and we'll assign the IP address as shown in the topology. So just go to the router 1 and then CLI and just put here no, and then enable, then config terminal, and then interface. Then we need to go on interface mode, interface FA 0/0, and we need to assign the IP address as IP address, and it contains the IP address 192.168.1.1. Yes, and it has a subnet mask 255.255.255.0, and then we need to make this port off, so we need to write the command as no shutdown. Get the point? And then just exit from this port, and let's go to the interface FA 0/0, and then we need to go on, we are on FA 00, and now we need to assign the IP address, and the IP address for the we need to go on a serial port, not a FA 00. For FA 00 we have already assigned the IP address, so now we need to go on a serial port. So let's exit from here and then go to the interface serial 000, and for serial 00 we have the IP address, and it is 100.0.0.2, and its subnet mask is 255.0.0.0. Then we need to write no shutdown, and then so we have done our work. So just end the command, and we can see our work. For that we can use a command show IP interface brief. So we can see that fast Ethernet 00 contain 192.168.1.1, and it is off. Serial 000 100.0.0.0.2, and it is also off. And we have seen that we can see that the router 0 previously the port serial 0 is showing down previously, but now if we check by using the same command, we can observe that the serial 00 is off now, because the adjacent port of a router 1 is up now. So due to this reason, the router 0 containing serial 00 is also off for now. So we have done a basic configuration. We have done all the basic configuration. We assign the IP address to the host, we assign IP address to the server, we assign IP address to the router. Now our aim is to do static NAT. So for the static NAT, there are some steps. So first step is in a static NAT, static NAT is a one-to-one connection, one-to-one. So I'm just opening the notepad. So what we can consider that, so static NAT is one-to-one type. It means every private IP needs a single every single private IP needs a single public IP. So what do I mean? I mean, if PC0 contain 10.0.0.10, so it this is the private IP, so it needs a public IP. And for now, I assume the public IP for the 10.0.0.10 will be 50.0.0.10. This is my assumption. And similarly for 10.0.0.20, the IP address will be 50.0.0.20, and 10.0.0.30. For now I am not assigning any public IP to the 10.0.0.30 for the testing purpose. We can see that after configuration of static NAT, PC0 APC1 is converting it mapping to the public IP, but PC2 will not map. This is for the testing purpose. Okay, so now this is the work done on the LAN 1 side, and for LAN 2 there is also private IP, and the private IP is 192.168.1.10, and for this I am assuming the public IP address as 200.0.0.10. So what we have to understand that the private IP and the public IP must belong to same class, or also we can say that the subnet marks, or also we can say that the number of network bit present in a private IP is equal to or it same to be the number of network bit containing in public IP. So I mean the number of network bit in private IP must be same as of number of network bit in public IP for the NAT, for the static NAT translation. If you do not do that, it will show a conflict IP addressing. So you must understand that the number of network bit in private IP and in public IP, it must be same. So this is my assumptions. And now the static NAT has a three steps to configure static NAT. The first step is we need to use a command to map this. Step 1 is known as a mapping of what? Mapping of private IP to public IP. Mapping of private IP to public IP. So for that we can use a command in configuration mode. We can use a IP NAT inside source static, IP NAT inside source static, and then we need to mention the private IP and then its public IP what we have assumed previously. We can give any IP, but for now I just assume this IP. We can give any IP of class A. So step 1 we are just mapping, and then in step 2 we just need to define the LAN. In step 2 we need to define the LAN. So for LAN we can use IP NAT inside command, and in step 3 we just need to define the WAN, and for WAN we can use a command IP NAT outside. So let's do now. We can see how it works. So the first step is to assign the IP addresses. The first step for the NATing is to map the IP address. So now our aim is to map this private IP into the given public IP address as we assumed. So let's go to the router 0, and then let's go to the configuration mode. So just type config terminal. Will be on configuration mode, and after configuration mode we can use this command as I have already right here. We need to type IP NAT inside source static private IP and then the public IP. So let's write IP NAT inside source static, IP NAT inside source static, and the private IP. So for now, the first TC0 contains the private IP as 10.0.0.10, and 10 for the 10.0.0.10 we have assumed what? We have assumed a 50.0.0.10 as a public IP. So the command is IP NAT inside source static private IP, and for this private IP, what is the public IP? Just we have assumed 50.0.0.10 as a public IP, and just enter the command, and then again IP NAT inside source static private IP was 10.0.0.20, and then its public IP, as we have assumed, 50.0.0.20. so this is a private and public so this is the private to public mapping. And for the 10.0.0.30, that is for the PC2, we are not mapping the IP address to know that there will be no NAT, because we have not done the mapping. So this is the first step, step 1 for the static NAT, and after that we need to do the step 2, and in step 2 we must define the LAN, and in step 3 the WAN. And it is not necessary to do first define the LAN and after then WAN. We can do any one of first. It will be not matter. So now let's go to define the LAN. We must introduce the LAN port, and for now the LAN port is a interface FA 0/0. This is the LAN port, and we need to type the command IP NAT inside, and then we need to exit from this port and need to go on a WAN port, and WAN port was interface serial 0/0, and then we need to type IP NAT outside, and then just type end. So the basic static NAT has already done. Now we need to go on a router 0, because router 0 also contains the server which has a private IP. So for this 192.168.1.10 we have assumed a 200.0.0.10, that is this both private and public IP belongs to class C. So let's go to router 1 and enter into router. Unfortunately we are on a we are in user mode, so first we need to go on privilege mode. So for that we need to type the command enable. Now we are in a privilege mode, so let's go now. We need to go on configuration mode. And then we need to type the IP NAT inside source static for the mapping. So the command is IP NAT inside source static, and private IP. The private IP is 192.168.1.10, and for this we have assumed the public IP as 200.0.0.10. The private and private IP must belong to same class. So the first step has been done. Now we need to go on a LAN port. For LAN port, the LAN port is interface FA fast Ethernet 0/0, and we need to write the command IP NAT inside, and just exit from this, and then again we need to go on a serial port and interface serial 0/0, and then we need to type IP NAT outside. So this will be our NAT static NAT. So the static NAT has been done, but if you check the NATing, it will not show because there is a two router, and it means they are on a WAN connection, and to get the reachability from router 0 to router 1 and router 1 to router 0, we need to do a routing. For now I am doing static routing. We can do any dynamic routing, we can also do the default routing, we can do the reap, we can do the OSPF. So for now we just doing the static routing. So we know how to do a static routing. I'll explain how to do a static routing. So we need to do static routing on both router, that is router 0 as well as on router 1 2. So first let's go to the router 0, and in router 0 we need to be on configuration mode, configuration terminal configuration mode, and then the syntax to make static routing is IP route. First of all we must be on a configuration mode, and then we need to type IP route, and after the IP route destination network, and the subnet marks of the destination network, and then exit interface. So IP route and destination network. Currently we are on a router 0, and for router 0 the destination network will be 192.168.1.10 and the exit interface is 100.0.0.10. So IP route destination network 192.168.1.10, but this destination network 192.168.1.10 has been mapped into public IP, as we have assumed, that is the public IP for 192.168.1.10 is 200.0.0.10. so we need to mention here public IP, not the private IP. Okay, so we need to type IP route destination network. So destination network is a 200.0.0.0 and the network is a 200.0.0.0 because 200.0.0.10 is what? 10 is a IP for the host, and we need to put here the network ID. We need to put the network ID, not a host ID. And the network ID is a 200.0.0.0. And now we need to mention also the subnet max, and the subnet max is 255.255.255.0. And the exit interface, and the for the router 0, the exit, if this is the destination network, the exit interface or the exit IP is 100.0.0.2. so we need to mention 100.0.0.2. so IP route, where is the router 0? Yes, IP route destination network and the subnet mask of the destination network, and there is exit interface, and the exit interface is 100.0.0.2. this is okay, and just end this, and now we need to do the same task from the router 1. So for router 1 we must go to the configuration mode, and then we need to mention static routing, that is IP route, and then destination network. What is the destination network? Destination is a 10.0.0.0, but the 10.0.0 network is already mapped into the public IP as 50.0.0.0. so we need to mention the public IP address, but not the host IP address. We need to mention the network ID. So network ID is 50.0.0.0, and it has a separate marks of 255.0.0.0, and the exit interface is, we can see from the topology, the exit interface is 100.0.0.1 from the router 1 side. So 100.0.0.1. so this way we just done the static net as well as a static routing too. Now we have already done a static net as well as a static routing. So after completing the topology and configuration, we need to test that the given private IP will be mapped to the public IP or not. So for that we can see it from the host and router 2. So first we are going to test from the PC0. So let's go into PC0, and then we need to go on a desktop and then command prompt, and in the command prompt mode we are going to test. So ping is a good command, ping is a testing command. Now I'm just writing ping and the destination network 192.168.1.10. so I am pinging private IP from the PC0. So it means if we ping the private IP, so it shows that there the NAT configuration is wrong. There is a no static NAT configuration because we cannot reach private IP of the server. So let's do just after typing the ping and destination network, just enter the hit, just hit the enter. We can observe that the reply is a destination host unusual. It means we cannot access the private IP. Now we are going to ping on public IP address. So for now we have assumed that 192.168.1.10 is mapped into 200.0.0.10. So let's IP the public IP, and the public IP is 200.0.0.0.10. and if we get a response from the public IP, then it can be considered as the static NAT has been done. So let's see, request timeout, it's showing the request timeout, and again it's showing the request timeout. Okay, so now we just get the reply. So we can see the loss percent is 50. So this is the system error, this is not our error, not our error. So if you ping again, we can see that we get no packet loss, that is a 0% loss. We will get a 4 out of 4. So this is so the first one is the system error. So we can just remove that system error by pinging next time. So from here we can observe that we are accessing the public IP, not the private IP. So it means we just configure the static NAT. We can also check from the PC1. So let's go to the PC1 and then the command prompt and just type ping and the 200.0.0.10. So we are getting the reply. And previously I have already said to all of you that PC2 contains 10.0.0.30 and 10.0.0.30 is not mapped to the public IP for the testing purpose. I have already said in our beginning. So we can also see here 10.0.0.30 is not mapped to any public IP. So let's check. If you ping the public IP from the PC2, it will say no response or something like destination or all disabled or request time out, because this private IP does not map to the public IP. So it is showing request time out. Good. Also we can check the static NAT from the web browser. We can go to the any PC. For now the any PC is PC0 and PC1. So let's go to PC0 and then go to the web browser. It will take some seconds to open the web browser. I don't know why this is a system error. And just type the public IP on URL address like 200.0.0.10. So we get a response. It means the static has been done. It can be also checked from the router 0. So let's go to the router 0. And then we must be on a privilege mode and just type the command show IP NAT translation, and we can see that inside local is a private IP, inside global is a public IP, as we can see. So this is the also verification way to know the mapping of private IP to public IP. So we can see that the 10.0.0.10 is mapped to 50.0.0.10 and 10.0.0.10.20 is mapped to 50.0.0.10. So this way we can do static NAT. So if you have any confusion, you can comment on the comment box. Thank you.